Out of the pages of science news, we have learned that an octopus can predict who will win the next soccer match. That the chicken really does come before the egg.
The chicken must have come first. No word from the UK as yet on where the chicken came from.
And that a study by an epidemiologist says Santa Claus promotes obesity and drunk driving. Hello and welcome to CU Science Update. I'm your host, Beth Bartel. So, a clairvoyant octopus isn't really a science story, but it received much uncritical attention in news outlets. British scientists did claim that they had definitive proof that the chicken came before the egg, but the story ignores how chicken eggs themselves could have evolved. And finally, if journalists did their research about the Santa story, they would have learned that all of their information was based on a study that was simply meant to be a joke. The craft of reporting science news has its challenges, not to mention the decline in science and research coverage by many traditional news outlets. In newsrooms that are struggling economically, science coverage is often considered to be an expendable luxury, and the first to be placed on the cutting block. For example, in 2008, CNN eliminated their entire health and science department. And recently, the BBC cut a quarter of its already small science reporting staff. Left behind are journalists who are simply inexperienced when it comes to reporting science. Many of them rely heavily, if not exclusively, on press releases, and their stories show little scrutiny and hardly any critical analysis. This can be a problem, especially in a world where science plays a crucial role in our lives. We expect journalists to bring us the latest discoveries with accuracy, objectivity, truth, and scrutiny, the same values that science itself uses. Although journalists don't have to be scientists themselves, they still have to do their homework, learn how to translate lingo and technical material, and explain its relevance to the general population. Still, lazy reporting might mean that some science will get misrepresented or go unreported altogether. And attempts at balanced reporting sometimes means that fringe science is given as much airtime and credence as the genuine science, often reinforcing the notion that scientists can't agree on anything. But despite the declines in science reporting in traditional newsrooms, we're starting to see an explosion of science journalism in blogging. And many of these blogs are being published by experienced science writers. Award-winning British science writer Ed Yong's Not Exactly Rocket Science blog, or Phil Plate's badastronomy.com, or Alice Bell's blog Through the Looking Glass are just a few of the hundreds of examples. Another is the group blog Boing Boing at boingboing.net, a science and technology site that features stories about gadgets, art, and futurism. Boing Boing got its start as a magazine in 1988, but in 1996 they became a web-only publication. Boing Boing has twice won the Bloggies for Web Blog of the Year in 2004 and 2005, and they started a podcast called Boing Boing Boing. We are pleased to have with us in the studio Boing Boing's science editor, Maggie Koerth-Baker. A journalist who's written about a wide range of science research, Maggie's work has been published in Discover, Popular Science, National Geographic News, Scientific American, and Mental Floss. For Boing Boing, she covered breaking news on the nuclear plant disaster and the aftermath of the Japan earthquake. CU Science Update correspondent Ted Burnham spoke with Maggie, who was invited as a speaker to CU's 63rd Annual Conference on World Affairs. She tells us about the complexities of reporting science in breaking news stories and the risk of misinformation in a media culture that is always racing to get information to the public quickly. We are pleased that Maggie could squeeze us into her already busy conference schedule. She arrives in her studio fresh from one of her many panel discussions.
So Maggie, you're here for the Conference on World Affairs, and it looks like you're on a really crazy variety of panels, everything from comic books to pandemics and superbugs to alternative energy. How did you become involved in such a wide variety of panels here?
Well, I am finishing up work on a book about the future of energy in the US, so that's how I ended up on those panels. But I was just so excited about the whole concept of how the Conference on World Affairs works. Like, when they told me to send them a list of things that I'm interested in, I think I might have sent them possibly too long of a list. And just ended up getting spread out all over the place. I'm really excited about the session that I'm doing on urban agriculture also, which I am just starting to garden for the first time in my entire life, but I was able to kind of find some really cool research on how human beings change plants by growing them in cities. So how these plants adapt to the urban environment on an evolution basis, and also how the urban environment affects plants that were bred elsewhere and then just grown in cities. So it's really interesting stuff, and even if it's not something I was an expert in, I was able to find cool tangents to kind of take it off on.
Oh, that sounds like a really exciting opportunity to bring all the different things that you've been interested in professionally. I mean, people probably know your work from Mental Floss, Discover Magazine, National Geographic, et cetera, even if they may not recognize your name. But being the science editor for Boing Boing, that's where I first ran across you. And I'd love to hear how you first became involved in Boing Boing. And what is Boing Boing exactly, for people that don't know?
Boing Boing is a tech and culture blog. It's been around for a decade, I guess, at this point. And before that, it originally started out as a print zine made kind of, not non-professionally, but amateur print zine from the late 1980s that has kind of had this long history of finding the interesting unnoticed cultural artifacts and technology and how those two things interact. And it's kind of evolved into something that has, possibly a wide as mix of topics as the Conference on World Affairs itself. So we have everything from privacy rights issues to the science stuff that I do to lolcats. So it really runs across the board. And I got involved with them because my first job out of college was at Mental Floss magazine. And when I decided to go freelance, Mental Floss offered me the opportunity to write a book for them, which was kind of a, one of those trivia bathroom reader type of things. And part of the promotion for that was guest blogging on Boing Boing. And after my guest blogging stint, I guess I did a good enough job that they asked me back as a, well, not full-time, but, hired on science editor.
So what's your role as the science editor? Do you go over other people's postings, or is it your job to make the science stuff happen?
Mostly my job to make the science stuff happen. The way Boing Boing works is that everybody, and there are 4 owner editors who write for the site, as well as me, and also we sometimes get things from the managing editor, and our tech people occasionally will post to the site as well. Everybody writes whatever they want to write about. We don't really run by each other what we're going to write about the next day as a matter of course. That does happen sometimes, but then it's usually like, I think you know more about this subject than I do. Can you give me some pointers so I make sure I don't screw it up while I'm trying to write about it? So that is where I do some of the more traditional editor type of work. Some of the other editors at Boing Boing will come to me and be like, this is a really interesting story. I want to make sure that, see how this fits in with, what you know about science. Do you know anything about this topic? Can you give me some pointers on what sort of questions to ask if I'm going to do this interview? And so I help them out with that kind of stuff, but that's by request. The rest of what I do is, partly my job is to look around the internet and find really interesting science stories that you might not necessarily notice otherwise, and kind of aggregate them onto Boing Boing. And then I also do original reporting for Boing Boing as well. So I'm set up to start doing 2 feature stories a week starting next week. So I've got a couple things ready to go for that.
Excellent. So it sounds like a very different environment than traditional, like a print magazine.
Very different, yeah.
Would be.
Yeah.
How does it compare to your experience at Mental Floss and freelancing?
I have almost no oversight at Boing Boing. I write about whatever I want to write about, and that's really good in that I can, I don't have to sell anybody on the idea before I toss it out there, even at least a little bit of it out there, which is exciting. But at the same time, it's a little bit scary because you're playing without a net to a certain extent. There's no copy editors. There's nobody checking my grammar, checking my facts. I have to do all of that myself. And it's really changed a lot about the way that I do journalism compared to how I was taught to do journalism. In journalism school, we were taught that you never show your sources your story, for instance, before it goes to print. And that's something that I have found to not be useful in science journalism, that particular rule, because I find that the art of taking technical science subjects and translating them into something that the general public is going to find interesting and also understand, you often have to make analogies or tell stories that can make little changes to the science that can make it wrong. So if I am able to send the full draft of a story to my sources and they can read through it and tell me whether something is misleading, I can avoid some of these little mistakes that end up perpetuating out into people being misinformed. And that's really, really valuable, and it's something that I have since started doing with all of my journalism.
Speaking of people being misinformed, the crisis in Japan, I feel like we have to talk about this because the Boing Boing coverage was really interesting to me. That Jenny, one of the other editors, she posted some stuff immediately, and then you came in the day after with sort of a day after wrap-up post, kind of pulling together more sources from around the internet, it seemed like, and then continuing to follow what was the best coverage and what do we know, what don't we know, how is the situation evolving. So how did you handle that? Because it was such a big issue and continues to be with a lot of misinformation floating around.
Yeah, Sheni and I have coordinated a lot on that, kind of talking about how to use Boing Boing in the way that it is best suited to in situations like this. And one of the things that I wrote that got a lot of viewers was an article kind of explaining how nuclear reactors work and what had actually kind of happened to cause this problem. And I think I put that up, I guess the day after day after the earthquake. But it gave me an opportunity, because it's Boing Boing, because we don't have to be the first person to have the breaking news. We had this opportunity to step back and see what the people trying to do breaking news are covering and see what they're missing and what questions they're bringing up that aren't getting answered, and try to then answer them in our space. And I think that's a really, really valuable role that Boing Boing can play when it comes to fast-breaking science stories like this, because I don't have the resources to keep up with everything that's going on the way the New York Times does. But I can do some of these follow-up stories that get a little bit more in-depth to things. So for instance, one of the things I'm going to be doing in kind of the aftermath of Fukushima nuclear reactor disaster, I have started to see, or rather in the aftermath of the earthquake, I started to see people mentioning, does this have to do with global warming? And so, which sounds silly, earthquakes being affected by climate change, but there is apparently actually some small research that's been done suggesting that there is a connection between earthquakes and climate change, having to do with the shifting weight of ice from the polar caps melting and then adding to the weight of the ocean in places where it was, not as deep before. And I don't know exactly how, I don't know yet how accurate that research is, or whether it's research that scientists think is correct, most scientists think is correct, or whether it's kind of a fringe thing. But that's something I'm going to be looking into in the weeks to come, to kind of go back to these questions that are getting overlooked because they aren't breaking news.
Mm-hmm. Some of the other issues with the reporting on the Japanese crisis has been about the hype over the radiation threat, especially here in the States, and that's been picked up by the mainstream media with confusion over radiation and radioactivity and what's a safe dose, and are we getting anything that matters? And it seems like this just, this should be relatively easy to answer, but it just won't go away so far.
Well, I think part of why it's not relatively easy to answer is that the situation isn't at a stable place yet. The breaking news keeps changing. So what you can say about, who's safe and for how long, it keeps changing as well. And I think also it's a very complicated subject, both because of the many different units of measurement that you're trying to convert between, based on what it is you're measuring and what kind of effects you're looking for. And there's all these different isotopes of radioactive isotopes that do different things and have different kinds of effects on the body. And it becomes this giant load of information that's really difficult to sift through. It's not as easy as you might think. I'm actually kind of trying to right now verify some information that I had posted on Boing Boing before that may or may not be correct now, and I'm trying to go back and find out what is the case and what isn't the case, and it's kind of hard to get clear answers.
That sounds like a luxury of working online, though, that you can go back and correct yourself. You can make edits to an article and updates.
Yeah, you can, but at the same time, I mean, it's. I think when I do figure this out, instead of just making edits to the article, I'm going to make a new article, and I think that's really the privilege of working online, is that I can make my corrections as prominent as the original thing was. Mm-hmm. You know, I don't have to have it buried in a little corrections box somewhere on page A13.
So that will help, or can help journalists to address any initial mistakes and to really put a rumor to rest.
It can. But it is difficult to do sometimes. Sometimes it's really easy to find the correct answers, and sometimes it's not. And it can take a while to get those things hashed out.
Mm-hmm. You mentioned a book that you're finishing up about the future of energy. Has the events in Japan, have those changed anything as far as the role that nuclear might play in our future?
I'm going to have to update some of the book to reflect that this has happened. But what my book is about is not necessarily specific technologies so much as it is trends. So what I'm trying to do is pull back from specific technologies and specific projects and look at what these things all coming together are telling us about the way that how we think about energy is going to change. So, for instance, I'm looking at the rebound effect with energy efficiency, which is the tendency to, as you are able to do the same work for less energy, then doing more work and spending more energy. So if you have a car that has a good gas mileage, maybe you drive more, for instance. Or if you have a factory that has equipment that is more energy efficient, they might take the profits from the money they saved on energy and invest it in more production. And then the other thing is the decentralization of energy, which nuclear power does come into play somewhat there because it's a very big centralized source of energy right now. And it's not as, like, those large, there are several reasons why those kind of large power plants in the middle of nowhere aren't as profitable as they used to be. And we are seeing some shift to energy production on the scale of regions within states or communities, rather than multi-state gigantic generation of, that's been kind of the norm since the 1940s or 50s. And then the final trend that I'm really looking at is the lack of storage on our electric grid, which is a big part of why we can't just shut down all of the nuclear plants and all of the coal plants and go immediately right now to wind and solar, because as our grid is set up right now, we have no way of storing electricity to use it for later. Mm-hmm. And it's going to be a lot more difficult than it initially seems to incorporate that into the grid structure that we have right now.
It sounds like a lot of challenges out there. Is there what are some of the bright lights on our energy front?
The bright lights are that we have the technology. We're not waiting for a miracle thing that's going to solve all of our problems. We don't have to wait for that. We have off-the-shelf technologies that already exist, that are already viable, that we can take and use to not completely eliminate our dependence on fossil fuels, but to really start to make our energy mix significantly more diverse. And we can do that right now, and that's a really big bright point for me. The downside is that it's a complicated thing. Because it's not one simple solution, you have to have all these different things working together, and they can't operate by themselves. They have to work together, and that becomes a difficult logistic thing to pull off.
Mm-hmm. Well, it sounds like there's going to be an even greater need moving into such a complicated and important future for science journalists like yourself and good science reporting.
I certainly hope so.
It's possible that competition with blogs could motivate science journalists in traditional media to think more critically. Awards that are given to good science bloggers are based on whether their writing is clear and precise, how well they made the science relevant, and most especially, whether they write interesting stories. If you want to learn more about science writing, the Council for the Advancement of Science Writing has listed some key organizations in the U.S. and internationally. They include the Association of Healthcare Journalists at healthjournalism.org, the National Association of Science Writers at nasw.org, the Society of Environmental Journalists at sej.org, and the World Federation of Science Journalists at wfsj.org. All of these organizations are dedicated to advancing public understanding of science. To learn more about science blogging, you can visit the website scienceofblogging.com, where you can get tips from some of the best science bloggers. That's all the time we have for this edition. We'd like to thank Maggie Koerth-Baker for taking the time to visit with us and sharing her ideas. There will be more shows to follow with other guests from CU's Conference on World Affairs, so stay tuned. In the meantime, you can see other CU Science Update episodes on iTunes, or you can visit our website at cuscienceupdate.com. And don't forget to like us on our Facebook page. See you next time.